Alright guys, today we are going to talk about day 2 of regular polygons, which is going to use trigonometry. So to do that, we need to remember our trig functions. If you do not like the 30, 60, 90s and 45, 45, 90s, this is another way you can do that. So here we go. So let's start here. You'll notice that this is already filled out. I messed up the first video, of course. So I'm going to talk through this, guys, with you guys again. So the first thing you need to do is label each side as opposite, adjacent, and hypotenuse based on the angle measure. So the angle measure here is theta. So I usually start with the hypotenuse, which I labeled with pink, which is always opposite the 90-degree angle. Then I go to the theta and I follow that across to the side opposite it, so that's why this one's marked opposite. And then I do the adjacent last because the adjacent tends to be the hardest, so if it's the last one there, I can easily do that. So it's next to it, so that's adjacent. So if you remember back to our trig unit in January, we use this phrase SOHCAHTOA. And SOHCAHTOA just helped us remember what went with sine, what went with cosine, and what went with tangent. So sine was opposite over hypotenuse. Cosine was adjacent over hypotenuse, and tangent was opposite over adjacent. So we use that to help us when we got into our trig. So sine is the opposite over the hypotenuse with the ratio, and you always put that angle on the inside. So whatever your angle measure is would go here. Cosine is the adjacent over the hypotenuse, adjacent over hypotenuse. Again, the angle measure would go here. And tangent is the opposite over adjacent, so opposite over adjacent, and I didn't even use the right color there, so this would be blue. So that would be opposite over adjacent there. And again, the angle goes on the inside. So you should have already watched the video to do your construction on the regular pentagon. That should have been the first thing you did, and then you had one more construction to watch, and you should be done with your construction portfolios to turn in on Wednesday. I made a mistake, so I drew the images for you guys here. So that is what is going on here. Okay, so it's really blurry, and I'm sorry about that. I cannot fix that. But we are dealing with regular pentagons. So a pentagon has a total of 5 sides, so our n is 5. If you remember back to Friday, we revisited the formula from before spring break that helped us find the angle measures inside of a regular polygon. So we use this n minus 2 times 180 over n. N minus 2 is the number of triangles you can draw if you start only at one vertice, and 180 is the degrees in a triangle. So that gives you the total degrees in a pentagon. Since all the sides are the same, you divide by 5. So I do 5 minus 2 times 180 divided by 5, and I get each of my angle measures is 108 degrees in the pentagon. So I know that every single one of my degrees here is 108. Now the big thing we have to remember is that this triangle here cuts that angle in half, so if I divide that by 2, it is 54 degrees. So again, we know that to find the angle measures, we're going to do this. N minus 2 times 180 over n, where n is the number of sides, which is 5 in a regular pentagon. Now, to do this, you'll notice that it's a 54-degree angle because we've been taking out that triangle there. So if you remember, we took this single triangle out and pulled it out, and we then went back and counted the number of triangles. But if we're taking that triangle out, we're taking out a 54-degree angle here. Well, 54 degrees is not a special triangle, so we can't use our 30, 60, 90s. We can't use our 45, 45, 90s. We're at a loss for what to do here, but that's why we taught you guys trig. And again, if you do not like those 30, 60, 90s or 45, 45, 90s, you can use the trig the whole time. So I pulled that triangle out. And right now I know my perimeter is 30 inches. Well, if there's 5 sides in a pentagon, if I do 30 divided by 5, I get 6. So each of my sides is 6 inches, which means that this part there is 3 inches. So the part of my base of the triangle I pulled out is 3 inches. So you guys have to remember that we are needing to do the area of a triangle, which is 1/2 base times height. We have our base, but we do not have our height. We do not have our height. So that's where we need to look next, and that's where SOHCAHTOA comes in. So we have to label our sides opposite, adjacent, and hypotenuse. So my hypotenuse is the opposite the 90. My angle marked is 54 degrees, which would make this side the opposite, and 3 is my adjacent. So I have my adjacent information. So I'm going to be using cosine or tangent, but I don't need my hypotenuse. I need my opposite. So the one that has my opposite that I need is tangent. So I do tangent of my angle. So tangent of 54 is equal to the opposite, which I'll call x, over my adjacent, which is 3. We multiply by the denominator first. So I have 3 times the tangent of 54. So you're not using this calculator, but all of your calculators have the sine, cosine, and tangent button pretty much right out front for you. So you guys can use the sine, cosine, and tangent button. We're going to be using the tangent. So I do 3 times tangent of 54. And I get 4.13. So x equals 4.13. So that is my height. And you can round to 2 decimal places, that's completely fine. So I have a base of 3 and a height of 4.13. And we have to remember this is only one triangle. So we need to go back to this and figure out how many triangles are in this shape. And we kind of discussed this on Friday when we talked about how there's 2 triangles per side, so there should be 10 in here. But let me just show you that. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are 10 because there's 2 triangles per side. That would make sense that there's 10 triangles total. So we're going to have to multiply by 10. So just make sure you guys are aware of that. So we then do our area equals 1/2 base times height. So we do 1/2 of 3 times 4.13. So I do 0.5 times 3 times 4.13. And that's 6.195. So I have a single triangle of 6.195. So I still need to remember that I am multiplying by 10 total triangles. So I have to take that and multiply it by 10, and that is 61.95 inches squared. Okay, so that's the first one. Again, I'm sorry that this isn't on the actual notes sheet. I accidentally messed up and had my calculator in radians and not degrees. So that was my issue there. All right, so the next one there, let's do the same thing. So again, the steps are the same as Friday. We're just not using special rights. And if you hated those special rights, just don't use them and you can use the SOHCAHTOA instead. So we have an apothem, which is the one that's dropped to a 90-degree angle to the base of 3. We did this beautiful formula up here and substituted in 5 to get that each of my angle measures was 108 degrees. So that is important that we realize where that's coming from. So each of these is 108. So from there, we knew that when we take this little triangle out over here, so if I pull that triangle out over here, this angle here is not the whole 108 degrees. So we have to take half of that, which is 54 degrees. Again, that's not a 30, 60, 90 or a 45, 45, 90, and hence why we're using trig. We know that this side here is 3 for the apothem, and we need to find the area, which is 1/2 base times height. So we already have the height, and we just need the base. So we label our sides. Opposite the 90 is the hypotenuse. Opposite the angle is my opposite. And next to my angle is my adjacent, which I always do last. To do base times height, I know my height. I just need my base, which is on my adjacent side. So I have my opposite and my adjacent again, which again is tangent. So tangent of the angle, which is 54, equals opposite, which is 3, and I'm going to call adjacent x over x. We always, always, always multiply what's in the denominator first, so I get x tangent of 54 equals 3, which means we still need to divide by tangent of 54. So I do 3 divided by tangent of 54 in my calculator, and I get 2.17. So my base is 2.17. Nope, no, that's 2.18 if I'm rounding correctly. So we now know my base and my height. So remember, we're doing one triangle first. We know that since there's 5 sides and there's 2 triangles per side, there's a total of 10 triangles here. So we'll multiply our final answer by 10 because we have 10 triangles. So to do the one, I do 1/2 of 3 times 2.18. And I get 3.27. So one triangle is 3.27 inches squared. So that's only one. So the fact that we still have 10 to do, we have to multiply that by 10. And I get 32.7 inches squared for my area of my pentagon. So a few things you'll need to know for your test is you'll need to know how to find the angle measures of any regular pentagon or any regular polygon, which you can use with the triangle, the square, the pentagon, the hexagon, and the octagon. You can use that with all of them. You also need to either know, you need to know 30, 60, 90s and your trig or just your trig to do this. So just make sure you're focusing on what makes sense to you, but you can't use 30, 60, 90s or 45, 45, 90s here. And the last thing you really have to remember is to multiply by the number of triangles inside of your shape. That's going to be the thing you guys forget the most. All right. So you should have already watched how to construct a regular octagon. You should have your construction portfolios done. You should be done with that there. If you are not done with your construction portfolio, they are due Wednesday, so make sure you're getting to those and watching those YouTube videos that are posted in the classroom. So let's move on to a regular octagon now. So remember, an octagon means that there are 8 sides. So to find the angle measure, I do the n minus 2 times 180 over n. And this time my n value is 8. So I do 8 minus 2 times 180, and I divide that by 8, and I get 135 degrees for each of my angles. So each one of my angles are 135 degrees. But we know that this triangle here that we are going to be pulling out does not have that whole 135. In fact, it is half of the 135. So I take half of 135 and I get 67.5. So this is 67.5 degrees. All right, so this one gives us the radius. The radius is from the center to a vertice, so it is actually giving us this one here, which is neither the base nor the height. So that means we are going to be doing a lot of trigonometry here to figure out both those sides. So you're going to have to use trig more than once to get to those sides. Okay. So I'm going to call this x, this y. This is my opposite, my hypotenuse, and my adjacent. Opposite, or hypotenuse is across from the 90, opposite across from the angle marked, which is my 67.5, and adjacent is my other one. So if I'm working on finding my height first, that is my opposite and my hypotenuse. Opposite and hypotenuse is the sine. So I'm going to do sine of 67.5 equals x over 6. So to solve for that, I multiply both sides by 6. Again, you guys have the trig buttons. You have sine, cosine, and tangent directly on your calculator. So you do 6 times sine of 67.5 in your calculator, and you get 5.54 for your height. And then you need to use your trig to find the adjacent side. So if we're looking at the adjacent in the hypotenuse, adjacent and hypotenuse is the cosine. So we'll do the cosine of 67.5 equals y over 6. We multiply by that denominator first. Remember, the angle measure always goes inside the trig function. That's why that's there. So I do 6 times the cosine of 67.5, and I get 2.296, so that's 2.3. Okay, so we have our base and our height to be able to find the one triangle and use area equals 1/2 base times height. So I'm going to do 1/2 of 5.54 times 2.3. So we have 0.5 times 5.54 times 2.3, which is 6.371. So 6.371. But that is only one triangle. So we have to remember, my guess is that there's 16 of these in there because there's 2 triangles per side and there's 8 sides. So that's 8 times 2, which is 16. But let me just show you. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So yes, we have 16 triangles, which means we have to multiply by 16. So there's 16 triangles here. So we're going to take that and we are going to multiply by 16. And I get 101.936, so I'm going to do 101.94 meters squared. So again, the same kind of concept we've been using, just with trigonometry. So last one, we have our side lengths are all 5. So all of my sides here are 5. So that means that in my little triangle here, half of 5 is 2.5. So we take the little triangle out, and I know that my base is 2.5, which is super nice for us because that means we're only finding one of the sides this time. We found out by using this formula up here that all the angles are 135 degrees. Again, remember that formula. And half of 135 we found from this one is 67.5. So this angle here is 67.5 degrees. So we just need to find our height here, which means we're only going to have to use one trig function this time, which is nice. I label my hypotenuse, my opposite, and my adjacent. So I have my adjacent. I need my opposite, which leads me to the tangent. So I do tangent of the angle, which is 67.5, equals opposite, which I'm going to call x, over 2.5. We always multiply by what's in the denominator first. So I multiply by 2.5, which gets my x alone. So I can do 2.5 times the tangent of 67.5 in my calculator, and I get 6.035, so that's 6.04. So x equals 6.04. So I now have my base and my height. One of my triangles, one of my 16 triangles is what I'm finding here. So area equals 1/2 base times height. So I'll do 1/2 times 6.04 times 2.5. And I get 7.55. But remember, that's only one triangle. There's 16 of them. We need to multiply by 16. So we take that and we multiply by 16. And I get 120.8. So 120.8 inches squared. All right. That is your lesson. Good luck on your homework, and I will be back tomorrow.